Welcome to the lecture series of numerical methods. Today the topic which we are going to discuss is solution of Laplace equation. Let us consider the process of solving the Laplace equation in two variables, that is dou square u by dou x square plus dou square u by dou y square equal to 0 with boundary condition. We assume that u of x comma y is required region. After finding all the values of u, we can improve their values by using an iteration formula. The formula is u of I comma j power n plus 1 equal to 1 by 4 u I minus 1 comma j of n plus 1 plus u I comma j plus 1 of n plus 1 plus u I plus 1 comma j of n plus u I comma j minus 1 of n, which is called Libmann's iteration formula. If we start the iteration process by computing an improved values of u1 by means of Libmann's formula, the new improved value of u1 denoted by u1 of 1, then we proceed to improve u2 in the same manner, and the process is repeated as long as it produces two consecutive values are equal. So this is the process under solution of Laplace equation. So how we are going to do the problem is the Laplace equation, okay, in two variables, dou square u by dou x square plus dou square u by dou y square. Instead of writing like this, it can be written as del square u equal to 0 with boundary condition will be given in the question. So what is our aim? Our aim is to find the value of u. This is the u of x comma y is the required value. How we are going to find the value means in the rectangular region only. It will be given in the question. The region also will be given in the question. So within that only we are going to find the value of u of x comma y. So u of x comma y is understood that u1, u2, u3 according to the question the values of u may be differ. So we are going to find all the values of u by using the iteration formula. That iteration formula is called it as Libmann's iteration formula. So for finding the solution of Laplace equation, we are using the Libmann's iteration formula. So you are starting the iteration process by computing the values of u1, then the next iteration u1 of 1, then the next iteration u1 of 2. Like that we are improving the value of u1 by the iteration. So once we have completed, once you have arrived the two consecutive values of u1 are equal, then we will proceed the same procedure for u2. Okay, so this is the procedure for finding the solution of Laplace equations under the unit 5. So look at the question. So the question is, solve the Laplaces del square u equal to 0 at the interior points of the square region given in figure. So the question itself, it's given the square region. Look at the region of finding the solution is given 0, 11.1, 17, 19.7, 18.6. Likewise, the region is given in the question itself. Look at the point, these points also given u1, u2, u3, u4, u5, u6, u7, u8, u9. So we are going to find the values of all the 9 values of u. Okay. So based on the procedure, we are going to do this. As we have discussed in the earlier video that the beginning values of the u1, u2, u3, u4, we are going to find the standard 5-point formula and diagonal 5-point formula. Okay. So for the solution, look at this diagram. The value of u1, u2, u3, u4, u5, u6, u7, u8, u9. For all these, we are going to find the initial value first. So already we have discussed in the first video, that is in the previous lecture, the points are called mesh points or grid points. So here we are going to take the 9 points. So in this one, so look at the solution. Let the values of u at the interior points be, see, instead of finding u of x comma y, we are taking the interior points. The points are u1, u2, u3, u4 up to u9. So we are going to first initialize the value of u. How we are going to initialize the values? By using the standard 5-point formula or diagonal 5-point formula. So standard 5-point formula means we are using the neighboring points. That time we can use standard 5-point formula. If you are taking the diagonal points, then we can apply the diagonal 5-point formula. So using these two result only, we are going to initialize the values of u1 to u9. Okay. So look at this given region. In this one, first we are going to find the initial value of u5. Okay, for this question, this is the procedure. You have to remember like that only. For u5, how we are going to find the value means, you can go for the boundary values. See, the values given in the outside of the region, it is called it as boundary values. So when you are initializing the value of u5, how we are going to find the value of u5? 0 plus 17 plus 21.0 plus 12.1. That is left, right, above and below. So this is nothing but what? This is nothing but our standard 5-point result. So for initial iteration, we are going to use standard 5-point and diagonal 5-point result. If you are applying these two results, we can initialize all the values of u1 to u9. So for the initial iteration, better you draw a diagram like this, because whenever after completing the iteration, you can immediately mark the value to get the equal values are same. See, if it is not possible to draw the diagram like this in the examination due to lack of time, if you are not doing this one, as usual how we are doing the iteration method, like that also you can do. It's not necessary, it's not compulsory, but to avoid the mistakes, and we can do like this. Okay, so initial iteration u5 of 0. So we are mentioning the initial iteration as 0 by the notation 0, that is u5 of 0. That means initial iteration. 0 represent for initial iteration. What is that result? Standard 5-point result 1 by 4 into. Okay, 1 by 4 into. See, the left value is 0 and the right value is 21. So 0 plus 21.0, that is what given in the question. And then above value and the below value. The above value is 17 plus then the below value is 12.1. So if you want, you can write it in bracket standard 5-point formula. Okay, so which is equal to, using calculator we can get the value of u5, that is 12.5. So this is the initial value of u5. Why we are going for u5 means, because it's a centralized point, and moreover we can use the boundary values directly. That is the reason why we are going for u5. So after find out u5, where we can go? So if you want, we can write the u5 value, that is the initial value of u5 is 12.5. You can mark it then and there itself. Okay, so u5 initial value is 12.5. So next I am going to find the value of u1, that is u1 of 0. How we are going to find the value of 0? Just think about that. See, here you have a diagonal value 0, and here we have the diagonal value 17, and here also we have the value 0. Now only we got the answer of u5. So we can apply the diagonal 5-point formula to initialize the value of u1. Look at this one. See, these are the diagonal values of u1. Just to understand only, I am making the dotted line like this. This and all not necessary in the examination. Okay, with the seeing the diagram itself, you can do it very fastly in the examination. So now u1 of 0, that is the initial value of u1. Okay, u1 of 0, that is diagonal 5-point formula. So that is what? 1 by 4. That formula is nothing but what? 1 by 4. Look at the diagonal values 0, 17, again 0 and 12.5. Okay, so 0 plus 17 plus 12.5 plus 0. So the value of u1 of 0 is 7.3. Okay, so if you want, we can write it in bracket diagonal 5-point formula. Okay, it's not necessary, it's not compulsory, just to understand only we are writing this. Here it is standard 5-point formula, then we are going the u1 of 0, that is we are using diagonal 5-point formula. Next I am going to find the value of u3. You know why? Because here also we can apply the diagonal value. Look at this one, 18.6, 17.0, again 12.5 and 21. So for finding u3, we can use again the diagonal 5-point formula. Okay, so for u3 we can use diagonal 5-point formula. Just now we got the value for u1. What is the first value? Initial value of u1 is 7.3. Can write it here. It's understood, this box is for u1 value, so it is 7.3. Okay, likewise next we are going to find u3. After find out the u3, we are going to find out u7 and u9. Okay, first we will complete all the odd numbers, u1, u3, u7 and u9. Okay, first we have started the initial iteration for u5 using standard 5-point formula. Then u1, u3, u7, u9. For all the 4 points we are using diagonal 5-point formula. Then we are going to find the value for u2, u4, u6, u8. For these even numbers, we are going to apply the standard 5-point formula. Is it clear? So whenever you are finding the value of any point, that is u1, u2, whatever it is, then and there itself you mark the value in the diagram. Okay. The next one is u3 of 0. For u3 of 0, as I told you already that u3 is nothing but using diagonal 5-point formula. So 17, 18.6, 12.5 and 21. So using all this, we can get the value of u3. The value of u3 is 17.27. After that u7, for u7 also for diagonal point you can use. So 6.2, the u7 value is 6.2. How we are doing this? For the u7 also we are using diagonal 5-point formula, 0 and then 12.1. Here it is 0 and 12.5. It's not necessary to make the dotted lines, just to you understand only I am making the dotted lines. Okay, so you can get the value of u7. Likewise, you can get the value of u9. u9 value is 13.65. For this also we are using the diagonal 5-point formula. So after completing all the odd numbers, we are going for the even number, that is u2. For u2 we can use the standard 5-point result, that is u1 and then 17.0 and then u3 answer 17.27 and then 12.5. Applying these 4 values, we can get the value of u2. Likewise u4 and u6 and u8. All the initial values I have mentioned in the diagram itself. 7.3, 13.5, 17.27, 6.5, 12.5, 16.1, 6.2 and 11.1, 13.65. All the values are initial iteration value. So what are the result we have applied? For all the odd numbers we have applied diagonal 5-point formula. For all the even numbers we have applied standard 5-point formula. So here also u6 and u8, for all that we have applied standard 5-point formula. So this is our initial iteration. Just now we have completed only initial iteration only. So what is the next step? Next we are going to apply the Libmann's iteration formula. So after applying the iteration result, we are going to get immediate values. All the values we are marking in the diagram, or if you want you can do it in as usual procedure. If two values are equal, we can stop the iteration. So this is what the procedure. So next we are going to apply the Libmann's iteration formula. Okay. So by Libmann's iteration formula, we are supposed to write the formula first. ui comma j n plus 1 equal to 1 by 4 ui minus 1 comma j n plus 1 plus ui comma j plus 1 n plus 1 ui plus 1 comma j n plus ui comma j minus 1 of n. When we are using this formula at the points u1 to u9, we can get the following result. So how we are going to apply this result? Look at the diagram. With the diagram you can do it very easily. Just you remember the result, write the result and all. But when you are doing the problem, you need not to come here to put n equals 0, n. Instead of that, directly while seeing the diagram itself, you can add the 4 values by divided by 4, you can get the value. Right? So just to understand the method only, we are writing all these things. Instead of that, if you are seeing the diagram itself, we can easily calculate the values. Okay, so for the first one, u1 of n plus 1. Okay. u1 of n plus 1 is nothing but what? 0, 11.1, u2 and u4. So applying these 4 values, we can get this. So 0, 11.1, u4 of n plus u2 of n. See, here the boundary value of u1 is, here it is 0 and here it is 11.1. This value actually you got it, initial value is 13.5, here it is 6.5. Okay, but in the generalized result of the Libmann's iteration formula, when you are applying the formula, how we are writing this? By this formula only. Okay, so ui minus 1 is the left value, that is 0, and then ui comma j plus 1, that is our 11.1. Then the remaining 2 I plus 1 comma j and n minus 1 is u2 and u4. Ma'am, why don't we use the initial value? Means when you are doing the iteration, we can apply the value, but here we are generalizing the result. That is the reason why we are writing here it is u4 of n and u2 of n. Is it clear? We should not write the value here because we are not doing the iteration here. We are initializing the value first, then we are generalizing the result. After generalization only, we are going to give the value for n equal to 0, n equal to 1. That is called the iteration. So here we are not doing the iteration, just we are writing the Libmann's formula, and how we are doing the iteration, for that only we are writing this result. So that is the reason why here we are writing u4 of n and u2 of n. Okay, likewise for u2 of n plus 1, that is the second point. Okay, for the second point, u1 of n plus 1. Okay, because already we have got the result for u1 of n plus 1. That is the reason why here it is u1 of n plus 1 plus 17.0 and then u5 of n 17.0, u5 of n and u3 of n. Okay, u3 of n whole divided by 4. Likewise, for all the 9 points we are writing the result. Okay, so from the generalized result only we are writing. If you are not able to write from the formula, okay, from this result you can directly go to the diagram. Take this one, u1 of n plus 1 equal to 0 plus 11.1, u2 of n, u4 of n divided by 4. This is for u1 of n plus 1 and u2 of n plus 1, that is u1 of n plus 1, because this point is already over for the generalization. So that is the reason why here we are writing u1 of n plus 1. Okay, u1 of n plus 1 17.0, this is just now we are going to compute. So u3 of n and u5 of n. Is it clear? By 4. Likewise for u3 of n plus 1, u3 of n plus 1 we have completed u2. Okay, so 1 by 4, u2 of n plus 1 19.7, then 21.9, u6 of n. Okay, look at this one, u6 of n whole divided by 4. Likewise for u4 of n plus 1. For u4 of n plus 1, 0, u1 of n plus 1 already we have completed, and then u5 of n and then u7 of n whole divided by 4 for u4 of n plus 1. Likewise u5, u6, u7, u8, u9. For all the 9 points we have written the iteration formula. So this is the generalized result. In this only we are going to give the value for n equal to 0. What will happen when n equals 0? We can get the first iteration u1 of 1. Is it clear? That time we can get it here u4 of 0, u2 of 0. u4 of 0 is nothing but initial value of u4 and u2 of 0 is nothing but initial value of u2. Likewise only we are doing the iteration. Is it clear to you all? Likewise for u2 of n plus 1, put n equal to 0 so that we can get u2 of first iteration value, that is u2 of 1. u2 of 1 is nothing but u1 of 2 because n equal to 1. So 1 plus 1 2 and here it is n equal to 1. n previous values we are applying, we can get the value of u2 of 1. Likewise we are going to get all the iteration value of u1, u2, etc. u9. Okay, so this is the procedure. So now we are going to give n equal to 0 for the first iteration, n equal to 1 for the second iteration, like that only we are going to do. So for the first iteration, put n equal to 0. So we can get u1 of 1, that is the first iteration, n plus 1. So n equal to 0, we can get u1 of 1, that is equal to 1 by 4. Look at the diagram, u1. Okay, so 0, 11.1 and then u4 of 0 and u2 of 0. Is it clear? Because u4 of n, u2 of n, n equal to 0. So u4 of 0, u2 of 0. So now we have the value of u4 of 0 and u2 of 0. u4 of 0 is 6.5 and u2 of 0 is 13.5. This is the reason why I asked you to mention the values in the diagram. It will be easy to do the problem. Okay, so when you are adding all the 4 by divided by 4, we can get u1 of 1 answer is 7.794. So u1 of 1 answer is 7.794. Like this you can note the values of u1, u2, u3 then and there itself, so that you can stop the iteration easily, because consecutive values are equal. Easily we can note in the diagram. Okay, so the next point is u2 of 1. Okay, for u2 of 1, how we are doing this? 1 by 4. Okay, 1 by 4 into, see this one, u1 of 1 and here it is 17 and then u5 of 0, u3 of 0. So using that we can get the u2 answer is 13.64. So u2 answer is 13.64. So for u2 of 1, 1 by 4, u1 of 1, okay, u1 of 1, 17 and u3 of 0 and u5 of 0. So using all the 4 values we can get the u2 answer is 13.64. Likewise for the u3. So u3 also we can say this one, u2 of 1, 19.7 and then 21 and u6 of 0. So with the diagram itself you can complete the problem. Okay, so this 13.64, 19.7, 21.9, u6 of 0 is 16.1. So using all the 4 values we can get the value of u3. u3, the first iteration value is 17.842. 842. Likewise we can go for all the values, that is u4. u4 of 1, the answer is 6.611. Okay, and then u5 answer is 11.87 and then u6 answer is 16.09 and then U7 answer is 6.609, and then U8 answer is 11.059, and then U9 answer is 14.23. Okay, so this is only the first iteration we have completed. Likewise, put n is equal to 1 in the Libmann's result. Put n is equal to 1. Okay, so what will happen when we are substituting n is equal to 1 in this one? We can get the second iteration, u1 of 2, u2 of 2, u3 of 2. Just you write like that. After that, with the diagram, you can substitute the values directly and do the problem. Okay, for u1 of 2, again we can go for the value of 0, 11.1, and here it is 13.64 and 6.611 by 4, so that we can get the u1, and u2 means again the previous value of u1 and this 17.0 and then 11.89 and u3 value. So substituting all the values divided by 4, we can get the u2. Likewise, we can do the problem until we get two consecutive values are equal, we can stop the iteration. Okay, so for this problem, the third and the fourth iteration values are equal, so we can stop the process up to fourth iteration. So in this diagram I have noted the values, so instead of writing all the things I have marked in the diagram itself. So look at the third and fourth iteration value of all the points are equal, so we are stopping the iteration till fourth iteration. Okay, so the final solution, therefore the solution of the Laplace equation is, we have to write like this: u1 is approximation only, equal to 7.83, u2 is 13.66, u3 is 17.89, and u4 is 6.60, 11.95, and u6 16.29, and u7 is 6.64, u8 11.26, and u9 is 14.34. In this problem, the question consists of 9 points. That is the reason why we are doing up to 9 points. According to the question, the points may differ. Okay, so this is what the problem under solution of Laplace equation. It's an important question, and moreover the question will comes under 16 marks.